Good morning, everyone. Today we are going to start the new chapter, that is force and pressure. In this chapter, we will learn about concept of force, effects of force, unit of force, net or resultant force, different types of force, pressure, atmospheric pressure, and some numericals based on pressure. So we'll start with the first topic, that is force. We are all familiar with the concept of force from our common experience. For example, while performing the acts of opening a door, kicking a football, beating a drum, etc., we have to act in many ways. Opening a door, lifting a bucket, or picking up an object are the acts of pull. Kicking a football, throwing a ball, and beating a drum are the acts of push. Stretching a spring, filling a balloon with air, compressing a ball of plastic are the acts of changing the shape of a body. The effects needed to push or pull or change the shape of the body is known as force. So exactly the force is nothing. Force is only a push or a pull or both. A force cannot be seen, but we can feel and observe the effect of force. So here we are using two words for force, either push or pull. So what is push? A force to move an object away from our body. That is known as push. And what is pull? A pull is when we apply a force to move an object toward our body. That is known as pull. So force is simply either push or pull. Now a force has both magnitude and direction, making it a vector quantity. It is represented by capital F and measured in the SI unit of Newton. Some other units are also used for the magnitude of force, that is dyne and pound force. Force are due to interaction. An interaction of an object on another object results in a force between the two objects. For example, if a man stands behind a the car does not move. If he pushes the car, he applies force and the car begins to move in the direction of the applied force. So that means there is a interaction between the hand of the man and the car, and therefore the force is applied. So force arises just due to the interaction between the object. Now, if we are talking about the magnitude of force, so already we have discussed it is a vector quantity. That means it has direction and magnitude both. So, if we are having two forces and both the forces are working on the same direction, like you can see in the first example, in example A, there are two forces which are acting on a body and both are acting on the same direction. So, that's why the resultant force will be the sum of these two forces. That means F1 plus F2. Now you can see in the second example, here two different forces, F1 and F2. Two different forces are acting on the different directions. So that's why the resultant force will be the difference between these forces. So F2 minus F1. We can have some more examples. Like again, see the first example. In this example, two different forces are working on a particular object and both the forces are working in the same direction, 10 Newton and 20 Newton. So overall, the resultant force will be the sum of these two forces, that is 30 Newton. Now see in the second example, here two different forces are acting on the object in two different directions, 20 Newton and 40 Newton, two different forces in the opposite direction. So the overall resultant force, that will be the difference in these two forces, that is 40 Newton. 40 Newton minus 20 Newton, that will be 20 Newton. That is the net resultant force. Now what will be the direction of that net resultant force? That will be the direction of the force with the higher magnitude. That is in the direction of the 40 Newton. Now you can see in the third example, equal magnitude forces are acting on the different direction, on the opposite direction. So because they are present in the equal magnitude, so that's why they will cancel each other and overall there will be zero resultant. No force will work on that particular object. So these are the introductory part of the force. In our next video, we will discuss about the effects of force.